All right, this is Unit 4B. We are looking at the power of compounding. So we're looking at money here, and we'll be talking a lot about interest, both simple interest and compound interest. And the first thing, just wanted to give you a little scenario here. So on July 18th, 1461, King Edward IV of England borrowed the modern equivalent of $384 from New College of Oxford. The king soon paid back 160, but actually never repaid the remaining 224, and the debt was forgotten for 535 years. Now, upon discovery of this in 1996, a New College administrator wrote the Queen of England asking for repayment with interest. Now, if we're assuming an interest rate of about 4% per year, the administration calculated that the college was owed $290 billion based off of the, again, $224 that was not repaid. That was their calculation using what's called compound interest. Now, however, unfortunately for the new college, there was no clear record of a promise to repay the debt with interest, and even if there were, it would be difficult for this demand because the debt had been forgotten for over 500 years. However, this example illustrates the power of compounding. And it's a way that money grows when interest continues to accumulate year after year. So this, when we're talking about, this is a little bit of investments, and bank accounts fall under this, loans and those type of things. But the power of compounding, as you can see, is a very powerful principle. Again, going from $224 to $290 billion over 535 years. So we're going to look first at what's called simple interest versus a compound interest. And so it's all written out here. It's a lot to take in, but this hopefully will give you the idea of the difference there. So imagine you deposit $1,000 in Honest John's Money Holding Services, which promises to pay 5% interest each year. At the end of the first year, Honest John sends you a check and they take 5%, they times it by $1,000, and again, whenever you're doing calculations, make sure you change that percent to a decimal, times 1,000, which is $50. So you receive a check for your interest, and your balance remains $1,000. So they're just basically paying you that interest. So you get the same $50 payment at the end of the second year, and the same for the third year, and so forth. So after 3 years, they pay you out $50 a year. After 3 years, you have $150. So therefore, your original investment grew from $1,000 to $1,150 using a principle called simple interest. Okay, and this is where interest is paid only on your initial investment. Okay, and more generally, the amount of money on which the interest is paid is called your principal. Sometimes you'll see present value, principal. We're just talking about how much you initially invested. Now that's simple interest, again, where they only pay on the initial investment. They don't pay on the interest that you earn year after year. Now, let's switch gears here. Now let's suppose that you have $1,000 in a bank account that pays that same 5% interest once per year, but instead of paying the interest directly to you, it adds the interest to your account. So at the end of the first year, you get that $50 in interest, and it raises your balance to $1,050. So at the end of the second year, you get 5% interest again. However, this time, the 5% interest is calculated on the $1,050. So we take 5% times 1,050, which is $52.50. So the second year, you earn a little bit more. You earn $2.50 more in interest than the previous year. So your new balance, you take the 1,050 plus 52, and you have $1,102 after 2 years. Okay, then we continue for the next year. Again, 5% interest is computed at the end of the third year based off of the $1,102.50. So it gives you $55.13 in interest after 3 years. So notice that interest is becoming more and more because you have more money in that bank account. So at the end of 3 years, you have $1,157.63. So if you compare that, we had simple interest, we were at $11.50 after 3 years, and compound interest, we were at $11.57.63 after 3 years. Now, you can see that is an additional $7.63 more, even though you had the identical interest rate. And that's because, again, the bank is paying interest on the interest that you earn as well as the original principal amount. Now, this type of interest is what we call compound interest. And this is where things can get big really quickly. Depending on how much money you have in there, you can grow this quite substantially over time. So based off of that little introduction, here are some definitions to look at. So the principal in financial formulas is the balance on which the interest is paid. So this is what our interest is calculated off of. Okay, then again we mentioned simple interest is the interest paid only on the original investment and not on any interest that's added later. And then compound interest is interest paid on both the original and all interest that has been added to that original investment. So this question number 53 here, we are going to calculate the amount of money you'll have in each account after 5 years. Assuming that the account earns, and this one is, we're looking at just simple interest on this first example. So you deposited $3,200 into account with that's paying 3.5% as an interest rate. So one way you can think of simple interest is interest equals the principal amount times your rate. So sometimes you'll see R for rate. In this textbook, it uses APR, your annual percentage rate, and then times by time. Now, again, the percentage rate always needs to be a decimal, and time is always in years. So the interest here is going to be $3,200 times by 0.035. So that's 3.5%, so always change that to a decimal. And this is paid over a 5-year period. And so this will give us $560. So that's how much we would earn in interest over those 3 years, or excuse me, those 5 years at 3.5% interest. So the total amount in the bank account would be, or the total amount of the investment is $3,200 to start with, plus the interest of $560, which is $3,760 would be your ending balance after 5 years. Okay, so let's look at simple interest. Again, this little formula right here helps out with simple interest. Just the principal times the rate, or the annual percentage rate, APR, times the time in years. How many years are you earning simple interest? Now, compound interest is a little bit different here. So in compound interest, now this is for when you're being paid once per year. So I'm just going to kind of give you some definitions of what everything means in the formula, and then this bottom formula down here is the formula you're going to use in general. So whenever you see an A, that's the amount accumulated after Y years. So that's going to be the balance after, a certain number of years. We'll call that Y. So Y is in years. P is the principal or starting amount. Okay, so there's P right there. APR is your annual percentage rate, always as a decimal. Please don't forget that. And Y is in number of years. Okay, just a quick note. The starting principal P is often called the present value. So sometimes you'll see formulas that use PV. It's because we usually begin a calculation with the amount of money in the account at present. So that's why we have present value. The accumulated balance is usually called the future value. because it's the amount accumulated at some future time. Now again, always use APR as a decimal when you're doing this. So that's what all of these variables mean. But this is when you compound only once per year. You get paid interest once every single year. However, you can get paid interest more than once per year, and this is where our focus will be, is compound interest for interest that is paid n times a year. So for example, if you have a savings account, they usually pay every month, so that's 12 times per year. That's what we call the number of times compounding per year. So that changes our formula just a little bit here. We get the amount accumulated after the number of years. So A is equal to the principal or starting amount times 1 plus APR over n. Again, APR is the decimal, raised to the n times y power. Again, where n is the number of times compounded, y always in years. So make sure you've got a calculator on hand that is not a cell phone calculator. That's not going to... These calculations are really hard. With a cell phone calculator, I recommend a scientific calculator or a graphing calculator. And we're going to start going over some examples now, in the next video, I should say.